Next, we would like to introduce Pflughoeft. He's the Sentry Insurance Endowed Chair of Computational Analytics at the University of Wisconsin-Stevens Point. He has more than 20 years of industry experience applying data science techniques in his past roles as the Chief Analytics Officer at MaritzCX and the Head of Marketing Sciences at MarketPro. At both of these jobs, he won corporate innovation awards by solving difficult client problems with advanced techniques. Prior to his work as a data scientist, Dr. Pflughoeft served as a CIO for MarketPro, an international market research company. He led the transformation from snail mail phone surveys to web surveys and finally mobile questionnaires. Additional efforts included the automation of the sampling and reporting processes. He also was instrumental in setting up the Bangalore IT Center and led the efforts on security as a CISSP. Ladies and gentlemen, Kurt Pflughoeft.
Hello. All right, can you hear me? All right, great. Thanks for coming here. So this is kind of some work that I did at MaritzCX, which was my previous employer. Obviously, I don't work there anymore. But Maritz made it a little bit difficult for me to remove the logo here, but I just decided to go with that. So you can see the title of the talk is Using Data Blending to Create More Powerful Linkages. This is actually joint research with my co-author, Sharon Alberg, that's sitting in the back there. So this was kind of a fun project that we worked on a couple of years ago. So let me give you an idea as to the overview for the talk. On the first part of the presentation, I'm going to talk about what linkage analysis is. I'm going to say how is it related to mystery shop surveys. Some of you may not know what a mystery shop survey is, so I'll explain what that is. And then we're going to look at what is known as a simple linkage model. A simple linkage model indicates that there's only one predictor. This is actually something that's commonly done in market research. But then we're going to say, let's try to improve the performance of the linkage model. So we want to add some more independent variables. And so normally we would do that through data augmentation. Now there's really two different ways that you can do data augmentation. You can create a more permanent data repository through data integration. But I think a lot of us know that data integration can be kind of a difficult and time-consuming task. And so what we really want to do is we want to simplify and expedite that process through some sort of data blending technology. And the package that I'm actually going to look at is called Ultrix. And I'm going to lead you through that journey as to how much work it actually took to do the data integration, and then how it was so easily done in Ultrix. I was a little bit surprised by it. And then once we have all of these independent variables to create a more fully specified model, I will show you what those results are. So what is linkage analysis? In the context of market research, it's all about trying to predict some business outcome. In our case, we're going to try to predict sales. Now you can use a measure for simple linkage analysis from one of the previous steps here. So for example, if you looked at operational performance measures, you could maybe come up with a quality metric. That, by the way, can come from a mystery shop survey. And you could say, how good is that quality metric in terms of predicting a business outcome? Or you could look at a customer experience survey. You might be able to take a look at attitudes like customer satisfaction. How is that related to a business outcome? Or intentions like likelihood to recommend, and then finally behavior. But this is a very difficult task. We already know from the psychology literature that going from one stage to the next, for example, going from attitudes to intentions to behaviors, tends to have very low correlations. There's theories on this, theories of planned behavior, theories of reasoned actions, etc. So obviously trying to jump to business outcomes is difficult. So like I said, even though it probably doesn't make sense just to have one independent variable to try to predict something like sales, we do this all the time in market research. And so the most famous measure is called Net Promoter Score. This was kind of promoted by Fred Reichheld. The idea behind Net Promoter Score is pretty simple. It's something like you're taking a look at a question as to how likely are your customers to recommend your product or service. The idea is that if you have more customers that are more likely to recommend your product or service, that is going to be positively correlated with revenue growth. So it sounds very appealing. When I worked in market research, I think half of our clients use Net Promoter Score. The problem is that other researchers tried to replicate his research. One of them is Cunningham, and he found no relationship between Net Promoter Score and future revenue growth. But surprisingly, he got in the same situation where he came up with his own simple linkage, where he had something called a wallet allocation rule. And of course, it remains to be seen as to whether or not a simple linkage can really work. Intuitively, it makes a lot of sense. More successful corporations probably have higher satisfaction scores. They have higher likelihood to recommend scores. So it kind of works maybe at a macro level, but when you start looking at individual companies, these relationships don't really hold very well. So we know that this would be a misspecified model if we just had one predictor. Why is that? Because obviously something like sales is impacted by the competitive environment, by the state of the economy, and the list kind of goes on and on. Probably the most famous counterexample to Net Promoter Score is Wachovia Bank. Wachovia Bank had some of the highest Net Promoter Scores, and if you know a little bit of the history of Wachovia Bank, they did grow, but eventually they got involved in the financial crisis. They mismanaged some of their portfolio and assets, and pretty soon there was a run on the bank. The bank almost collapsed, but it was eventually acquired by Wells Fargo. So what we want to do is we know that in market research, we should have other independent variables to kind of predict something like sales. But the question is why don't we do that in market research? It's a lot of time, it's a lot of effort, it's a lot of cost. Normally when we do a survey, they want the results within a week or so, and we just don't have enough time or resources allocated to do a proper linkage analysis. So let me kind of explain where I'm headed here. So we had a client who was a major gasoline chain. They had thousands of gasoline stations throughout the United States. And what they did is they used to measure performance by a mystery shop survey, which I'll explain in a little bit. And I want to show you the simple linkage between a quality measure and sales for this gasoline chain. And then eventually we'll say, how can we improve that model by doing something like data augmentation? So what is a mystery shop survey all about? If you ask a gasoline station owner, they would say it's about a hammer. The idea is that the corporation is trying to see whether or not these gasoline stations or franchises are actually adhering to corporate policies and procedures. And so what corporate does is they'll hire a market research firm. We, in turn, will hire a bunch of mystery shoppers. Mystery shoppers kind of are like incognito, and they're going to not reveal basically the nature of what they're doing. They're going to act like a customer. They're going to make a very small purchase. But while they're making that very small purchase, they're kind of noting the condition of the gasoline station outside, inside, their interaction with the employees, etc. Now, I listed a few of the questions that you'll see on a mystery shop survey. Most of the questions would be checkboxes. Like, for example, were you greeted upon entering the store? Which of the following amenities were available? Things like, windshield washer, paper towels, those types of things. Usually on a mystery shop survey, you could have maybe about 100 or more of these types of checkboxes. And then what we would do as a market research firm is we would come up with a compliance score. In other words, how well did that gasoline station follow the company's policies and procedures based upon what? This mystery shop survey. And we would share those results basically with the gasoline station owners as well as headquarters. Now, sometimes the results from a mystery shop survey would be used for getting some sort of, reward or something like that. Other times it might be used for a penalty. And in fact, if you got too low of a score, you could actually lose your franchise because you're not really following corporate policies and procedures. So I think I kind of talked about that. Again, major gasoline station chain, thousands of gasoline stations. And I'm going to do a very simple linkage analysis. And the reason that I do a simple one is because this is kind of the norm in market research. So if you take a look at the x-axis, this is the overall compliance score that's being calculated from the mystery shop survey. It's going to range basically to 0 to 100%. I've got it in decimal form over here. And then I've got sales on the y-axis. This isn't necessarily raw sales because we had to do some sort of normalization so that large gasoline stations don't get a benefit just because they're larger, right? We want to be able to control for that and see what the relationship is between a performance or quality measure like a compliance score and sales. Now, if you look at this, the good news is that we've got a positive slope. As basically the compliance scores increase, you can see that sales also increases as well. The bad news is the R-squared is pretty low, right? It's only about 15%. So we've got about 85% unexplained variation in sales. But what we want to do with this analysis, especially when we get to a more comprehensive model, is we want to change the nature of the conversation. We don't want the gasoline station owners to think of a mystery shop survey as a hammer, but a way that they could use this information to improve basically their revenue for gasoline sales as well as convenience store sales. So we can present these results, but again, a little bit of a lower R-squared. I think we could probably do a little bit better. So if you take a look at some additional data sources, there's all sorts of them. For example, if you look at external ones, we could look at traffic flow patterns. We could see how convenient it is to go into the gasoline station, how to exit it. We could look at basically the area that surrounds the gasoline station. Is it blighted? Is it affluent? I could look at how many gas stations are in the immediate vicinity. These are all things that might impact gasoline sales. If we take a look at internal measures, I can look at other compliance measures, not just the overall one. We come up with compliance measures for the outside of the area. We look at inside of the store, staff, etc. And we also have some firmographics that are important. Some of those are supplied to us by the client. So for example, whether or not the gasoline station has a car wash, that might be an influence. So what I really wanted to kind of show you in this talk is, what is the difference between data integration and data blending? To tell you the truth, I really didn't know when I started this project. Because when I first did this project, it was a completely data integration task. I heard all sorts of words, and phrases, data blending, data munging, data scrubbing, I just thought maybe this is just another buzz phrase. And so hopefully you'll see by the end of this talk that, data blending is really kind of an important technology, and I really learned to appreciate it after this research study. So this is just kind of a brief summary as to what the difference is between data blending and data integration. Data integration is all about creating a permanent data repository, like a database. And so I would take a look at all of those variables that I showed you before and say, how can I create an integrated database? And then I could use that database to do all sorts of research beyond the simple linkage analysis that I was thinking about originally. But if you actually try to create something like a database, it's a lot of work, right? You got to come up with a design, you got to get other people probably involved, you got to figure out, how do I join these keys with foreign keys, etc. There's a lot of work involved. Data blending is kind of on the opposite end of the spectrum. Data blending is all about creating temporary data repository. And that temporary data repository is only used to answer this question. In other words, how are sales related to the independent variables. So obviously the technology that's used for data blending, you have to be able to do this very quickly. I'll just kind of give you an overview. When I did the data integration, it wasn't a required client deliverable. I think Sharon and I were trying to impress the client. So I kind of worked on this part-time, I think, for about 3 months in between other projects because I wasn't really getting paid for it. I think I spent 80 hours getting that database ready before I could actually run the models. I'll tell you that when I did it in Ultrex, and I knew nothing about it, is that it took me about 4 hours, okay? And so hopefully you'll get some motivation. And I think I'm pretty good with regards to IT, so it's not that I'm stumbling creating a database. So let me give you some insight on how to go about creating this. I did it in Postgres, and the reason I did that, it was a free database. It's very powerful, especially with regards to spatial queries at the time. So these are some of the data sources that I had to suck into the database. So for example, you look at the survey data. That's going to be the mystery shop data, right? You look at business outcomes and firmographics. Some of that's supplied to us by the client, okay? So they're going to tell us the sales. They're going to tell us, does it have, you know, a restaurant attached to it? Does it have a car wash, etc. Then I pulled in the US Census. The reason I did that is I had to try to figure out, is the gasoline station in a blighted or affluent area? And you might say, how did I do that? I looked at median household income to do that. I don't know if you've ever worked with the US Census data. Hopefully it's improved, but you know, I did this about 2 years ago. It's a mess. It's very difficult to grab the US Census data and put it in a form that you can do ad hoc queries. And so that took a little bit of work to do that. Then there's something called POI. Okay, it's not a Hawaiian food or anything, but I think it's a point of interest database, okay? And so some of you are familiar with this. I'm kind of old school, so I think I've Garmin and TomTom in my car, and when I go along the road, all these establishments pop up. Some of you probably use Google Maps to do that. But point of interest databases will help me get competitive information, okay? So I'll talk a little bit more about some of these data sources in a bit. And then the FCC, that's kind of surprising. Why is FCC there? It's not so much of a data source, but they have an API that lets you figure out for a given latitude, longitude coordinate, what census tract is it in, okay? All right, so what is a point of interest database? Well, the one that I used was called Factual. It's kind of like a digital yellow pages, so I'm kind of dating myself here. But you can find all sorts of information about, you know, the name of the business, hours of operation, all that type of information, especially latitude, longitude, which was important for me so that I could actually determine what were the competitive gas stations. So this one was called Factual. There are other ones like OpenStreetMaps. But I think one of the things that you have to be cognizant about when you look at POI is how comprehensive is it and how accurate it is, okay? So that is kind of the interface for Factual. There's 2 ways to get at the data. There's an interactive version here. You can see what I've done here is I've got a circle to indicate how many gas stations are within a certain area. And so you can see that there's 7 gas stations here. The center of that circle happens to be my house, okay? And so then what I did is I drove around to see, is that the right count? And it missed a gas station that was associated with Fleet Farm, okay? But I did a lot more of these types of tests, and I was pretty convinced that it was fairly accurate. If you look on the right side, that's the Python code to interact with their API. So remember, this gasoline station has thousands of gasoline stations, somewhere around 4,000. So each of those 4,000 gasoline stations, I have to find the competitive ones, right? And so I'm just showing you the code to grab for one gasoline station. Pretty easy to generalize to many. But you can see on Factuals, it says, you know, get the name, the address, the village or the town, and the latitude, longitude coordinates. That'll give me competitive information. If I look on the places filter, latitude, longitude coordinate, 5,000 meters for a 5K radius. And then 417 is just a category in Factual to indicate I'm looking at gasoline stations. The other thing I needed to do is figure out basically for a given latitude, longitude coordinate, what census tract was it associated with. At first I used the FCC API, If you get a little bit more sophisticated, you can pull in the US Census, GIS type of information, and once I have that into the database through Postgres, I can do these spatial types of queries. So you can kind of see their point, I list the latitude, longitude, coordinate. I realize that every country has, at one time, their own latitude, longitude, coordinate system because they thought they were the center of the universe. But the one that's commonly used here in the United States is 4326. So that's just a little query to show you how to get that information. All right, so now let me show you Ultrix. I always want to say Ultrix, but it's Ultrix. And it's a really powerful package. It allows you to do not only data mining, but also data blending. And the data mining is really kind of accomplished through wrapper functions associated with R. If you buy the package, it comes with a data source, which is the US Census. That's pretty nice because they did all of the processing for you, and you can query that data quite easily. TomTom is for routing information. We heard D&B from the keynote. D&B is great for medium and large businesses, but it's not so great for small businesses like a gasoline station, because some of the gasoline stations don't bother to actually register through D&B, etc. So I found D&B not to be very helpful. I ended up using Factual to get that information. Then we have Experian. They're the company that lost your credit card. No, they're the company that actually does demographics on individuals and households. And then Calibrate is pretty interesting. Calibrate actually has traffic flows. So I'm going to show you the first half of the workflow. The other half had to do with the data mining portion of it. Like I said, for me to set up this workflow and click on the icons and set the parameters, I worked a little bit with one of their systems engineers. It took me about 4 hours. I think if I had to replicate it, I could do it under 2 hours. We have the gasoline station file on the far left. That would have the sales, the locations, etc. for the gasoline stations under study. I have a geocoder to get the latitude, longitude coordinates. Sometimes that can be difficult because of the addresses, but the U.S. Post Office has a CAS program, which is a coding accuracy support system that kind of fixes addresses for you. I have D&B there, but I replaced that with Factual. And then I have US Census built into it, and then I do a geomatch. And the geomatch was originally to get competitive gasoline stations within a 5K radius, but then I learned that I could get a little bit more sophisticated with Ultrix, and I could do a 5-minute drive time. So this is Germantown, not a very big town, only 20,000 people. But originally I had used a 5K radius, but then I thought to myself, well, how much out of the way would I go to find an alternative gas station? I thought, well, maybe 5 minutes, and so that's the geometry associated with that. Now, of course, if you're a large city, you have to worry about on-peak versus off-peak traffic times, and you can get different geometries for that, but I didn't get that sophisticated. All right. So now that I have a lot of variables, I decided to run a little bit more sophisticated model than regression analysis. I did a random forest. One of the reasons, obviously, is to get nonlinear relationships if they exist. But more importantly, random forest does a very good job in terms of determining the importance of a variable. In other words, how much does it contribute to the prediction of sales? Now, if you look at the top variable, median household income, this is coming from the US Census, that is 30% of the importance in terms of determining gasoline station sales. Price is next. That's basically, I think we captured that from the mystery shop survey. We asked basically the people to record what the price was. And then we have fuel area. Anything in orange is going to be a compliance score. So instead of using overall compliance, I use the compliance score for fuel area, interior quality, exterior quality, and staff quality. I think if you add those all up, it's about 22% of the importance for prediction. There's a lot of other things like median age, percent of male, car wash, etc. We have the competitive gasoline stations, Exxon, Shell, BP, Chevron. By the way, I kind of changed some of this information, so hopefully you can't figure out what gasoline chain it is. But again, the competitive information, I think if you add that up, that's about 10% of the importance. What is really kind of the interesting result for this is to notice how much the R-squared went up. it went up from 0.15 to 0.47. So now I could go in front of basically headquarters as well as a committee of the gasoline station owners and kind of present the results and say, in the context of all these other variables, you can see that the quality measures that are coming from a mystery shop survey are pretty important with regards to sales. And so now, hopefully, we can get the gasoline station owners to look at a mystery shop survey, not so much as a hammer, but maybe a feather or something like that. So what are the conclusions for the research? Augmenting the data leads to much better results. Obviously, we went from 0.15 for an R² to roughly 0.46. Data integration is a difficult task. Again, I do have a fair amount of expertise on databases, but it took a lot of time and effort to do this. And so you have to bring in all these separate data sources. You got to figure out how to link the records at the right level. It really takes a long time. And I would not have been aware of data blending if it were not for a sales lady that pestered me for about 2 weeks straight. And I said, okay, I will finally try it. And when we actually got a copy of it with some of those data sources, I was just really amazed how quickly we could come up with results. And I think Sharon, I think the company actually still does this type of research now on mystery shop surveys. So it kind of changes the conversation a little bit with the franchise owners. You still have to do some legwork, and you have to have money. Alteryx isn't cheap. I think the base package is $5,000, but when it gets really expensive is if you want Experian data and all that type of stuff. You know, you could spend $80,000, and that's a per year cost. So, but it was really nice to have that data. It made it really easy to do analysis. And then the spatial capabilities, I wish I had a little bit more time to play around with that. But you can think about traffic flows that are associated by the gasoline station, etc. How does that impact sales? So I think in conclusion, I've kind of become a little bit of an evangelist for Alteryx, not a salesperson for them, but I really like that package, and I was pretty amazed how quickly we could link these data sources together. So with that, I'm done. Any questions? Don't be like my classes, they never have questions. Yes?
Any books you recommend to read more on this?
So there's on data integration in general, I think there's that one slide where I showed the difference between these two. It was called, I think it was Data Blending for Dummies. That's not too bad of a book. Actually, if you go to Alteryx's website, they have a couple of nice videos kind of explaining, you know, what the data blending process is all about and how you accomplish it. But yeah, it's a pretty neat technology. I wish I could actually afford it.
I was wondering how the adjusted R-squares worked on these models, or how it worked on pulled out data.
Yeah, adjusted R-squared really didn't lower the R-squared all that much. I mean, that's just some way, obviously, to account for the number of predictors. Obviously, if you have more predictors, R-squared can't really go down, it has to go up somewhat, but I think the adjusted R-squared, if I remember right, was 0.43 or something like that, so not much of an impact on it. But I think that makes sense, because if you look at the simple linkage model, it was misspecified basically, right? There's a lot of other factors that should have been included that weren't.
So in your results, I mean the R-squared, you improved the R-squared quite a bit with more data. But many of those, like for example, the location, the median household income, it's about 30%.
Yes.
So, and they cannot do anything about
That's
it.
exactly right. So, but that's not the whole picture, right? So if you took a look, for example, at compliance scores, that's 20%, right? Just because they can't do anything about it, I can't exclude it from the model, okay? I could maybe, do analysis segmented by different areas, whether affluent, blight, or somewhere in between, and control for it that way. But if you look at the compliance scores, it was about 20% importance. They can't do anything about the competitive gas stations either, right? That's about 10% importance. But I think the more important thing is that, these quality measures actually seem to have an impact on sales. And that's not too surprising. If you go to a gasoline station and the pumps are broken and they never have windshield washer fluid, or the compressor doesn't work, you know, you kind of get frustrated, and at least I used to tend to go elsewhere, so.
On the modeling part, you talked about R wrappers.
Yeah.
Did you find it was it pretty simple to, if you wanted to adjust some of the models using R? What is the, could you tell us just, what's the interface like?
So, like, when you take a look at some of those R packages and the methods associated with them, they could have a lot of parameters that need to be passed in. All of those parameters are kind of like on a web form page, and you just kind of go in there and change those. If you want to get into a situation where you have to write custom code, there's a node to do that, and you can use some of the existing R packages and do some manipulation on it. But I think it was very smart because, you know, last I had read was R had 60,000 packages between CRAN and GitHub. There's 20,000, I think, on CRAN alone. And so not all of those are available, obviously, but you can get at them through a custom R node wrapper, but it has a lot of them that you would expect, like boosted freeze or logit or whatever.
All right, I think we're out of time now, so thank you.
All right, thank you very much.